Mathematica. Now, Mathematica treats the inverse sign as what's called an arc sign. So arc sign means the same thing as sine inverse. And all I'm doing here is I'm plotting the inverse sign from -1 to 1. And the range goes from -π/2 to π/2. And so what we want to talk about today, Ralph, is we just want to know what the domain and ranges are for our inverse functions. We've got to remember them because when we use them in calculations, we've got to remember that our domains and our ranges are restricted. Okay? And there's a very good reason why. If you graph the sine function, the sine function looks something like this. But why does the inverse of that kind of function not really truly exist? That function doesn't have a true inverse. But why doesn't it have a true inverse? It is a function. It certainly is a function. It's a function because it passes the vertical line test. But it's not 1-to-1 because it fails the horizontal line test. So what we had to do last year was we had to restrict. We could only let it go so far. And we had to restrict. So we were going to keep this between -π/2 and π/2 last year. And that kept our function 1-to-1 inside that window. And so now what you have here is you have the inverse sign. So the inverse sign of x has to be less than or equal to 1, greater than or equal to -1. The values have to be between, I'm going to call them y. Y has to be between π/2 and -π/2. Okay? And so what I'm going to let you do right now is I'm going to let you play around with Mathematica just a little bit. So, and I'll guide you. I'll guide you. So Yvonne, I'll have you come up first. And what I want you to do is I want you to replace arc sine with arc cosine. So you're just going to go to my computer and replace the sine with capital COS.
Where here?
Where you see where it says arc sine?
Yeah.
Replace the, you don't have to erase all that, but just put the cursor at the end of the n.
What do you mean?
Put the cursor at the n in sine. Go over to the left. Okay, that's all right. No, don't go away. No, yeah. Okay. Put your cursor to the end of the n. Now you need a capital C, O, and then S.
Okay.
Yeah. Capital C. That's the thing about Mathematica. Mathematica's functions are always capitalized. Okay, now, what I want you to do is I want you to change this here, Yvonne. I just want you to say, make this -π to π for right now. So you can erase all that. Yep, capital PI. Now, the way that you run a Mathematica notebook is you hold the Shift key and then you press Enter. Okay. So, what we're doing here is we're seeing what's the domain of this inverse function. The domain is just the left to the right.
-1 to 1.
Yeah, -1 to 1. The range, however, is what? 0 to π. Do you see that it doesn't go below the x-axis? So that's the next thing that we need to write down in our notes. The domain goes from -1 to 1. Thank you. Didn't mean to really put you on the spot. But hey, now you know how to run a Mathematica notebook. So the domain goes from -1 to 1, and the range goes from 0 to π.
Didn't we type in negative pi?
We did, and notice, Tori, look at the graph. It has a whole bunch of empty space below the x-axis. So Mathematica is graphing it faithfully, but there's nothing to graph down there. So Mathematica is doing exactly what we tell it to. Okay, Tori, why don't you go up and replace cosine with tangent. It has to be a capital T.
Right-handed people.
Are you left-handed with your mouse?
Yes.
Hold shift and then enter. Okay, good. All right, now, let's see here. Could I have you change one more thing? Instead of x going from -1 to 1, I'm going to have you put x goes from -50 to 50.
Space or no space?
No space. And then
Shift enter.
Beautiful. So this is the inverse tangent that we're looking at right here. What do you think the domain is for the inverse tangent? What'd you say? I can't hear you. All real numbers, you're exactly right. So, Brian, I could replace the -50 with a -100 and it would still graph perfectly. Now, that makes sense because if you think about the tangent has an infinite range. It goes infinitely up and down. So the inverse function has an infinite domain. All right, so next thing we need to write down is we need to know, okay, the domain is from -infinity to infinity. However, what is the range look like?
Negative pi over 2 to pi over 2.
Yes, as a matter of fact. Now, is it going to include pi over 2? That's the question. Okay? All right, I'm going to have you, now I'm going to show you that it turns out to be not including negative pi over 2 pi over 2. Ralph, I'll have you come up to the keyboard real quick. Now, here's the first thing I want you to do. Put the cursor in front of the capital A in Arctan. In front of the capital A, yeah. And click on that.
Okay.
Yeah, now put a curly brace, a beginning curly brace. Now I want you to type negative pi over 2 with a capital P. Yeah, my key's missing. So it's the one where the key's missing.
Oh.
Yeah, over 2, comma, capital pi over 2, comma. Now right after where it says arctan x, put a closing curly brace. No, you can. So here's what we've done, Yvonne. We've graphed the line y equals negative pi over 2, y equals positive pi over 2, and then arctan. Now hold shift and then enter. There we go. Do you see that those are horizontal asymptotes? That's what we did, Brian. I graphed 2 horizontal lines. So the range goes from negative pi over 2 to pi over 2, but it doesn't include them. It gets closer and closer and closer to them infinitely. Okay? Thank you. So that's the next thing that needs to go into our notes. And this is going to become important because we're going to use these inverse trig functions down the road, and we need to know that when we use our calculator to find values, our calculator is going to give us restricted values. So that's why this is important. Okay, Brian, come on up. And I want you to replace tan with cotangent. And that's going to begin with a capital C.
Why isn't it? Okay.
So, cot. And for right now, let's just keep it the way it is. Let's just shift and then enter. Okay? We got something a little bit different here. So let's look at what we've got. It looks like the function has a vertical asymptote. This is what it looks like. at 0, it has a vertical asymptote. We can get rid of those lines, pi over 2 and negative pi over 2. So put the cursor before the capital A in arc cotangent. Yep. And then just hit the backspace, but don't delete the beginning curly brace. Just keep going to the curly brace and then stop. Yep, perfect. Okay, go ahead and hit Shift Enter again. All right, so do you see that we have a vertical asymptote? So the domain, what would we say the domain is for this function? Negative infinity to 0, union 0 to infinity. And what would we say the range of this function is? Definitely negative infinity to 0. Yep, union 0 to infinity, because it doesn't hit the x-axis, does it? So both the domain and the range are the same. Thank you.
Yeah.
But let's do this. Let's see. We've got negative 50 to 50. We're fine there. Looks to me that what I thought was a vertical asymptote really isn't. Because I think that's actually hitting the x-axis, the y-axis, Tori. I think it is. The domain is definitely negative infinity to 0, union 0 to infinity, so the domain hasn't changed. But Brian, I think what I thought was the vertical asymptote isn't. I think it actually hits the y-axis. And I think what's happening is it's hitting the y-axis at pi over 2 and negative pi over 2. How can you know? Let's plug it in. Remember, this is an arc cotangent, right? So this is an inverse cotangent. So the question is this. When you plug in 0 into the arc cosine, what should you get? So we don't have an arc cosine on our calculators, do we? So this is how we can do it, Yvonne. I'm just going to calculate it. I'm going to type in arc cotangent of 0. Calculates it for me. And technically, this isn't technically perfectly right because this is, well, this is true. This is pi over 2 here. If I type in, it should also say negative pi over 2 down here. So the range for this problem is going to go from negative pi over 2 to 0, but it doesn't include 0. Negative pi over 2 to 0, union 0 to pi over 2. That's the range of the function. All right, let's look at arcsecant. What would you say by looking at this picture? What would you say the domain is? Negative infinity to 0, union 0 to infinity, because it doesn't quite hit the x-axis here, does it? Or the y-axis. However, right here, let's look at the range. What does it seem to be approaching here as it goes up this way? Seems to be approaching pi, doesn't it? And then down here, seems to be approaching 0. So the range looks like it goes from 0 to pi. But now the question, Ralph, is does it include those points? So all I have to do to see if it includes those points is to calculate it. So what I'll do is I'll calculate the arc secant of 0 and see what happens. Okay, notice that Mathematica says complex infinity. That's basically a way of saying you can't get pi out of it. So Brian, what that means is that pi is a limit. It's not actually defined. So your range goes from 0 to pi, but it doesn't include those values. It doesn't include them. It just approaches them. And then the very last one, arc cosecant. Let's change that. Arc cosecant. There we go. Okay. The domain here is negative infinity to 0, union 0 to infinity. So it can't be, I can't hit the x-axis, the y-axis, excuse me. But I think what we have again, Tori, is we have another range that's a limit here. It doesn't really hit the values. What does it seem to be approaching here? It's definitely not up here, so it's not pi. Down here, -2? -2 is right here.
Negative pi over 2.
Yes, -π/2. So the range would go from -π/2 to 0 union 0 to π/2 for this picture. And you wouldn't use brackets. Right, because it doesn't actually equal -π/2, and it doesn't actually equal π/2. So it's parentheses all the way. Yep. Okay. All right. When in doubt, duke it out. We got 1 minute left. I want you to be able to do numbers 1 through 13. Now, those questions right there, Brian, they involve the domain and the range. Some of them may turn out to be undefined because they may be asking you to calculate a value that's not in the domain or the range. So you'll need your notes, what you just did, or we just wrote down, to do those problems, okay?
So you should actually do the problems or just find the domain and the range?
Well, whatever the problem's asking for. So find the exact value of sine inverse of -1.
So just keep the domain and range in mind?
Exactly. Yes, you'll need what your notes say about domain and range for these functions.